All right, let's take a look at topic 8B, starting with section 8.1, statistical questions and variables. So first off, a statistical question is a question that can be answered by collecting many pieces of information, data, or summarizing. Not just one piece of information, but many pieces. And I think the key here is there's an expectation of variability in the answer. So, meaning you're not going to get the same answer each time that you ask it. So that's what I would look for as the key. So, for example, statistical question, what month has the most birthdays of students at your school? There's lots of different answers. We'd have to summarize, we'd have to get everybody's birthdays, organize them, and all that. Not a statistical question, in what month is your birthday? That's one piece of information. That we can look it up, we're done. There's not variability. It's just, for me, December. That's it. It's always going to be December. So let's look at these four questions and see if they're statistical questions. If there's something we can answer with statistics. Which is the most popular visual art form? Photography, painting, sculpting, or drawing? Is this a statistical question? Why, yes, it is. Because many pieces of data can be collected. We have to get how many people like photography, how many people like painting, how many people, and then summarize it and compare them. So yeah, that's a statistical question. How many lithographs were created by the artist M.C. Escher? If you don't know, look them up. Got some good stuff there. That is not a statistical question. It's just one piece of data. Every time we look up that answer, it's going to be the same. It's always whatever number of lithographs he has. Next one, how tall are you? Not a statistical question again, because again, it's one piece of data. There's not going to be variability in our answers. It's going to be, for me, 6'3". That's it. It's not going to be 6'4", not 6'5", not 5'10". It's only one number. Now, how tall are the students in your class? So if we're talking about more than one person, then yes, that is a statistical question. So many pieces of data can be collected and then summarized, because we're looking at how tall all the students are. So we want to get a spreadsheet, we want to get some raw data, we want to get something that summarizes all of our data, many pieces of data. All right, so that's our statistical questions. Now within statistical questions we have variables. They're not quite variables like x equals 5, x equals 2, y equals 3. It's more of a characteristic or a category. Well, I guess it could be quantitative as well. So a statistical variable is a quantity or quality, so characteristic or number, that can be measured or counted, for which data are expected to differ from one observation from another. Two main types are categorical or qualitative, and quantitative or numerical. So we have, again, categorical and quantitative. And we don't really use qualitative because it's, I guess, similar to quantitative, so we'll just talk about categorical. So categorical variables, well, they fall into categories. That's why they're called categorical. So they're based on a physical attribute, not something we can quantify. but something that can describe. Whereas a quantitative variable is, I'm going to add a word in here, a numerical measure of data that can be compared, added, subtracted, or otherwise operated on. Has to be a measure. The example I always like to give, zip code. That's a number. Is it quantitative? No, it's not measuring anything. So zip code would be categorical because it's not a measure of where we live. It's just a grouping. All right, so let's, what is a statistical variable represented by the following questions? Is it categorical or quantitative? So what are we talking about here? So what breed of dog is most likely to be adopted from an animal shelter? So what's the variable? What's going to change each time? Well, the dog breed. And can we measure a dog breed? Can we see that this one's a little bit more golden retriever than this one? No, that doesn't make sense. So this is categorical. Categorize them by the type of breed. What is the average number of students per activity participating in after-school activities? Well, what's our variable? What's going to change? The number of students. I guess per activity. And that's a number, that's a numerical measure. We can count up how many students there are. So that is quantitative. And then letter C, what is your favorite Olympic sport? Well, obviously the variable is which Olympic sport you like. And this is categorical because we can't measure what sport is your favorite. You can classify it, you can categorize it, so it's categorical. Moving on to populations and samples. Population is a set of all members of a group that we want information about. So I'm going to add that in. So the population's what we care about, the info we want to know. A sample is a smaller version or smaller, subset of that population that's being studied to answer a statistical question about the population. So we use a smaller section of the population to kind of generalize to the whole population. So let's identify the population and sample of each study. A school newspaper randomly selects 30 students from each grade level to participate in a survey. So our population is all students in this school. It's everybody we want to know information about. Now our sample is what we can actually get information about. The 30 students from each grade level. So that's a smaller set. We're going to look at those 30 students, try and figure out whatever the survey is asking, and we're going to say, well, maybe that's the population's idea as well. All right, a city worker collects 5 vials of water from each of 10 randomly selected locations all over the city to test the levels of bacteria in the water supply. So our population. What are we trying to find stuff about? The full water supply of the city. We want to make sure that the water for the whole city is okay. and we're doing it all over the city, so that's our population. Now our sample is the 5 vials from the 10 locations. So that's 50 vials total. That's what we're using to kind of come up with our conclusion about the population, about the full water supply. Is it safe? Is it good? Or is there too much bacteria? All right, and lastly, a survey of 100,000 randomly selected American families gives a marketing company data on the TV preferences of the United States. So here, our population, all American families. We want to know what all American families prefer in TV. The sample, even though it's a big number, is 100,000 selected families. That's our sample. It's a very big sample, but our population is even bigger than that. All the families in the United States is a very large number. So that's the difference between population and sample. Population is the whole group, but we usually can't get information from the whole group, so we have to take a sample, a smaller section of the population, and get information from them. Now that information from them would be a parameter and a statistic. So a parameter, let's use a different color here, is a piece of information about a variable that is based on the entire population. So it's a variable, well, I guess it's information of a variable about the population. Whereas the statistic is based on a sample. It's a variable of a sample. So population, parameter, sample, statistic. That's how we can remember or figure out what we're talking about here. So is the following data a parameter or a statistic? In a randomly selected lunch period at the local high school, 24% of students brought lunch from home. This is a statistic. It's just the 24% of one lunch period. It's not the whole school, it's just one lunch period. A movie theater measures its total yearly concession sales and ticket sales to calculate the average amount spent at the concession stand per ticket was $8.14. Well, this is the total, or the whole thing, of the yearly concessions. So this is a parameter. Letter C, 53.25% of the district's eligible voters vote to re-elect a sitting U.S. House representative. Again, this is a parameter because this is of all the district's eligible voters. That's everybody that we can get in touch with. The median age of a car in 20 randomly selected spaces in the school parking lot is 7 years. Now that's just from the selected spaces, not all the spaces. So that is a statistic. Now, lastly, number 5 says change the scenario in question 4, A through D that we just did, so that the statistic becomes parameters and the parameters become statistics. Okay. So in letter A, we could just say 24% of the students in the whole school brought lunch from home. Now it's a parameter. Letter B, total yearly concessions and ticket sales to calculate the average amount spent at the concession stand per ticket. Well, we can change this to, I guess, let's do this. 30 random days sales to calculate the average. So we're not using all the days anymore, we're using just 30, so it's a statistic now. Letter C, 53.25% of the district's eligible voters vote to re-elect a sitting U.S. House representative. Well, that's our parameter, that's to everybody. So we can say maybe 32% of 100 surveyed people will re-elect the U.S. House representative. Lastly, the median age of a car in 20 of the randomly selected spaces. So we can say the median age of all cars in the school parking lot is whatever it is, 10 years. We're talking about all, so now it's a parameter.